Right. Hello, Eric. Uh, I'm, I'm going to talk about data science job market tonight, and hopefully you'll learn something useful for your job search. All right. First of all, a quick introduction to WeCloudData. We are based in Toronto. We're a Canadian data science academy, and now we have courses in the Eastern time zone and Western time zone as well. So we have students from US and Canada taking our data science and engineering upskilling courses. We're currently ranked as one of the best data science boot camps by SwitchUp. If you're interested in reading more about our data science course review, you can go to Course Compare. You can go to SwitchUp and check out our Google reviews as well. This is what WeCloudData do. We have different bootcamp courses. The data science diploma program, that's the bootcamp course as well. We have two different options, full-time and part-time. And we've been running that for 3 to 4 years, and it's quite a successful program. Right now, it's available in both part-time and full-time options. The next cohort is starting in November on the West Coast. We also have a business intelligence and data analytics program. This is a part-time program as well. And the next cohort is starting in early December on the West Coast. And we have a data engineering certification program. That's the data engineering bootcamp we run. It's available in both part-time and full-time option. The next cohort is starting in December on the West Coast, and it will be February 2023 on the East Coast. We also have a machine learning engineering bootcamp that's starting, just around the corner. It's going to start in November. This is an advanced level ML Ops and ML engineering program. If you're interested in learning more about computer vision, natural language processing, and also how machine learning works in production. So this is a pretty advanced level course and assumes that you already know machine learning foundations. And for anyone who would like to become a machine learning engineer, this will be one of the best courses out there. I would like to give everyone a quick overview of the learnings, online learning space. So there are a lot of great content online, right? If you're getting started with data science or business intelligence and data engineering, you can take an online course, right, from Coursera, for example, Udemy and Udacity. They have great course content. And colleges and universities have courses as well. There are also the traditional boot camps. Typically, boot camps will focus on project, right, hands-on projects and portfolio building, because boot camps are usually more career-oriented, right? So they will help you build portfolio, or at least help you get started. And of course, the students, after graduation, will need to keep building their portfolio while they're searching for jobs. And most of the traditional boot camps will provide career advisory service, and referral programs as well. But these are usually career advisors who, who are, from recruiting companies or just the internal, advisors. They don't necessarily work in data science, right? So they can help you with resumes, but they don't necessarily can guide you through the job search process. WeCloudData is one of those boot camps, but we offer different kind of services. I would say a more advanced version of that. So first of all the courses we have, we let the student work on portfolio projects. But instead of just a regular career advisory, we also provide industry mentors. So this is a one-to-one mentorship service, and the students will be working with a data science mentor who work in the industry to get their support on resume, mock interviews, and also when the students get interviews, the mentors will guide them through the process. And WeCloudData also has what we call the real life, or real client project. This is the type of projects that can help you build up your work experience, and you can directly add a real client project experience to your resume. That helps the students to fill especially career switchers, fill experience gap. So you're going to get a couple of months of real experience on your resume. So when you go for a job search, you're going to look a lot more experienced, and that helps students get more interviews. It also helps students, to have more talking points during the interviews, and also the students will have more salary negotiation power as well. Just a quick summary of the different options, right, in our data science programs. Right now, it's available on the West Coast. So we're going to start the West Coast cohort end of November. And if you would like to inquire about discounts for our, US and Canada West Coast courses, feel free to reach out to WeCloudData. There are three different options if you would like to, learn data science from WeCloudData. So we have the full-time immersive bootcamp, which is 12 to 14 weeks. So this is a full-time program. So student will study from 9:30 to 4:30, and then there will be TA office hours in the evening, like every evening as well. And students will be building portfolio projects, and real project, the industry project will be included. So these are not the type of projects where the school is getting a data set from some companies and let the student work on it. By real project, we mean that the students will be working on real consulting projects, will be interacting with the clients, and the work they do or the projects they create will need to be used by the business, right? So they're creating a lot of values for our business partners. And then we provide career support until you get a job, right? So some boot camps will say it's guaranteed job, but no one can guarantee your job. So it probably means that you're going to get some sort of refund if you cannot get a job. But if you've already invested 6 months in learning, refund is definitely not what you want. So with WeCloudData, we'll continue to support the students, whether it's spending more time on the real client projects. But our goal is to invest more, if the student need more support until you get a job. And right now, the price for the full-time program in Canadian dollars, 15,400. In the US dollar, it's 11,000, and we have early registration discount as well. For those of you who have already graduated from a bootcamp, certification program, or you have a master's of computer science or master's of data science, getting a job is not that straightforward. So if you still need help, right, and after you've acquired some of those skills, we have a project only option. So you can just enroll in the real project only program, and then we will guide you through the real projects, because for each project we have our full-time consultants as well as the project managers to team up with you to solve real challenges for our clients, and career services included as well. So you'll be working with a dedicated mentor for job search. We also have part-time program. So the curriculum is very similar to the full-time program. And if you're interested, if you have full-time job, you can't really quit your job to join an immersive program. This is 20 week, long part-time program. You spend about 10 to 15 hours a week, weekday evenings and over the weekend, to build up your portfolio. Real projects is not directly included in the tuition, but after some students, when they graduate from the part-time program, and then if they feel like they would like to add real work experience, they can purchase the real project as a separate package. And of course, career services included as well. All right. So that's a quick introduction to WeCloudData and the data science courses we offer. Now I would like to move on to the job market talk. First of all, let's try to understand the different types of data scientists, right? So I'd like to categorize data scientists into 4 different types. There are more types. And the reason why we see different types of data scientists is because data science is actually getting more specialized, right? So we have operational level data scientists, and these are the data scientists who work in a big business team, right? It's probably not a centralized data science team. So these are data scientists who are embedded into different kind of functional teams, right? So you'll find data scientists who work in marketing analytics, risk analytics. You'll find data scientists who work on the product side. And operational level data scientists, they are really good at SQL, right? Data manipulation, extracting data from databases, because that's very important. I think the data scientists should not be expecting data to be prepared by data engineers. You should always expect to know how to extract and prepare data yourself. That's very important data skills. And data scientists also need to know how to do visualization. It's not necessarily building a Tableau dashboard or Power BI dashboard, but even during your machine learning and predictive analytics effort, you will need to be able to visualize data and features so that you gain better intuition about the data. That will give you a better idea how to approach your machine learning problem, right? And of course, machine learning or applied machine learning skills are very important because a lot of the operational level data scientists will need to build predictive models, right, to help the company to do, for example, forecasting and or customer segmentation and predicting, for example, which customer is more likely to churn, right? And because the operational level data scientists, they work closely with the business, right? Communication skill is very important. You not only need to know how to process data, clean data, visualize data, and build machine learning models. You also need to be able to explain the insights, right, from your data analytics and machine learning back to the business, because the business users will be the end users of your modeling output. So if your model are not being used and trusted by the business, then there's no value in data science anymore. So of course, for product design, right, building recommender system, personalization experience, data scientists will need to wear the communication hat, need to be able to communicate well with the product managers, the software engineers, right? The communication is not always with the business side. Sometimes you need to be able to communicate with the tech team as well, like software engineering, data engineering, and IT as well. So the general business communication skill will be very important. And data scientists also need to be a good presenter, need to be able to do presentation. So that's the operational level data science jobs or roles. And I would say typically this is, accounts for 70 to 80% of the data scientist jobs out there. For example, take Meta or Facebook for an example. A typical data scientist at Meta, they don't build a lot of machine learning models. They actually, do product analytics, and they do a lot of A/B testing. So statistical knowledge is important. But the skills to work with data is very important. So SQL, Python, these are all very important. The second type of data scientist is what we would like to call ML researchers. Their job titles, are usually not data scientists, right? They are called research scientists, ML researchers. They do literature review. They, have the ability to read papers and implement novel algorithms. So they do a lot of implementation, not necessarily in production, right? But the work they do is very influential and important for the businesses, especially startups. The AI algorithms they develop might actually become the intellectual property for the startup, right? They work for, and they need to be very familiar with Python, C++, Java, data structures as well. So these are the ML researchers. The third type of data scientists, they're usually called ML engineers, ML ops engineer. These are the data scientists who have stronger software engineering skills, right? So machine learning engineers not only know how to build machine learning models, they need to be in charge of deploying the models in production. But whenever we're talking about production usage, the requirement on the software engineering side will become a lot higher because when we deploy things in production, we want it to always run smoothly, right? But as we know, things will always break, right? So when things break, the ML engineers will need to know, when we'll be notified when things break. So you probably need a little bit automation and ML ops capability so that you can do monitoring, right, of your machine learning models in production. And sometimes when things go wrong or your model prediction is not accurate, and that is probably because of the data, right? So data pipelining, data engineering is also very important skill that ML engineers need to have because garbage in, garbage out, right? So if the data that feeds into the prediction engine is not properly prepared and the distribution is screwed up, then the prediction on the other end will be meaningless. So ML engineering requires a different set of skills, but definitely there's a big overlap between data scientists and ML engineers, which is the machine learning and the deep learning part, right? And also all the math and statistical knowledge. But ML engineers will need to write more code. The code quality, the requirement for code quality is also a lot higher on ML engineering side. There's also the data science product owners and product managers, and sometimes they're project managers. The demand for product managers, right, in the data and AI space is going to be very high in the near future. And as a matter of fact, a lot of the data scientists, they will choose product manager or data product manager as their next career move, right? In companies like Facebook or Twitter, you'll find a lot of data scientists turning into product managers, and they become the product owner. This is a very interesting role because product owners don't usually manage a team, but they need to work with many different teams because they need to make the product happen. And they not only need to have great product ideas, they need to know how to turn that into reality, which means the product owners will be relying on data scientists to build machine learning models, will be relying on the data engineers to make the data available, and need to be working with software engineers to actually build the software product. So that communication skills, coordination skills, right, and even project management skills are very essential. If you want to become a successful product manager. But this opens up opportunities for the non-tech background product managers because people or PMs coming from traditional project management background, if they can gain some data science hard skills, right? Python coding, machine learning. They don't need to be expert, but at least understand how programming works, right? Understand the full end-to-end life cycle of machine learning will be very helpful because I once read an article which was saying that the market doesn't need more data scientists. It actually needs more product managers who understand data science. So that tells you the importance of product manager. And if you want to begin, your career as a technical data scientist, and just keep in mind that other than the traditional, corporate ladders, maybe you can just switch to product management, which I believe will be very exciting because you're in charge of a product or a product feature, and I think you'll have a great sense of ownership, and I think it'll be fun to work. Definitely be fun to work as a product owner or product manager at companies like TikTok, for example, because they're always pushing out really cool features. One suggestion I have, for anyone who wants to become a data scientist is that machine learning is very important. But I found a lot of beginners, they tend to focus purely on machine learning. I think data science, right? Data is very important. So machine learning is just part of the responsibilities. As I said, being able to manipulate data, visualizing data, business communication, these are all very important. And I'm assuming that a lot of you would like to get into data science. That's probably why you're here. So the operational level data scientist job is probably what you're aiming for. But if you come from a master's or PhD background in computer science, ML researcher, or the research scientist can definitely be a potential role for you to pursue. But the requirement on the math and algorithm side will be a lot higher. And you also need to keep in mind that there will be fewer opportunities like this in the job market. So majority of the jobs out there in data science will be related to operational level data science, machine learning engineering, and data analytics as well, right? Yeah. Okay, so before we start to talk about the job market, I just want to emphasize a few things, right, regarding the skill sets. So this is the data scientist Venn diagram. I think you probably have seen this many times, or different versions of it. In general, data scientists will need to be able to code, right? Coding is important, or programming, but it's not just writing code. I think data scientists also need to know different tools, and sometimes those tools are related to, cloud, big data, and data scientists, we need to know machine learning and mathematics for sure. We always get questions like, how much math do I need to know? And it's a good question. So our take on this is that if your goal is job oriented, right, and you give yourself 6 months to 12 months to become a data scientist, then you should focus more on the coding tools, data analytics, right, machine learning, and storytelling. So The job is actually very demanding, at least the interview process, right? So it's all about prioritizing your time. I'm assuming that if you're getting started, then there are so many different things you need to learn. You need to learn Python programming, right? Um, well, let's start from operating system, right? So if a data scientist want to work with big data and do coding, you need to have, some Linux, or command line experience, right? You don't need to be an expert, but knowing the minimum will be very helpful. On the programming side, I would recommend Python. R is a beautiful language. You can learn R as well. But I wouldn't recommend learning both at the same time, because imagine you only have 6 months to 12 months. You should, focus on one programming language and get really good at it. You can always add, R and some other, MATLAB or whatever, language, later in Java and C++. But if you want to get a job in 12 months, just focus on Python, because it's the most in-demand programming skills in the market right now for data science. And you need to be familiar with databases, right? For a lot of the data science roles, if you don't know how to write SQL queries, it means that you can't really, extract data. And then that's the starting point of any kind of a data analytics, which is, to get the data, right? So that means, writing SQL queries to interact with databases, and then you need to have foundational knowledge about how data is structured and stored in databases, right? So SQL is very important as well. Hopefully you understand version control. It's not always required, but I think if you want to become a data scientist, you definitely will need to learn how to work with version control in GitHub. And at least you want to know how to upload your portfolio to GitHub, right? So try to learn how to work with GitHub as well. So that's programming. And on the platform side, I think data scientists will need to know at least one, cloud platforms. You don't need to become an expert in AWS, but knowing how to work with AWS and launch some of the services will be very helpful if we would like to get a job in data science. Not all data scientist jobs will require AWS and GCP, because sometimes they're still, some companies still working in an on-prem environment. So on-premise means that everything is in their own data center. They don't really use the cloud yet, right? But the trend here, the macro trend here is definitely moving towards the cloud, even though the banks are trying to do that. So you definitely need to pick up one of the cloud, platforms. You need to know big data. I'll show you some of the live or the recent job market, trends regarding like the skill set, and big data is always among the top skills that data scientists need to have. But just keep in mind, I wouldn't recommend prioritizing big data over other things, right? Because I think machine learning is still the most, foundational skills you need to have, and along with SQL and Python, because not all companies have big data tools or a big data problem, right? But many jobs will, at least ask for Apache Spark and some sort of big data experience. It used to be nice to have, but you start to see more companies, asking about big data skills as a requirement. Knowing Docker will be very helpful as well. But I wouldn't say Docker is very important for data scientists. In some data scientist jobs, right? In some companies, data scientists sort of wear multiple hats. They work as ML engineers as well, because the team is relatively small. So if you want to deploy machine learning models, you at least need to know how to write code and deploy models in a Docker container, and then you just share that container with your software development team, so they can use that to do the production deployment. So yeah, Docker is probably the last step for a lot of the data scientists. But if you go work for like a bank or telecommunication company, they have they're more well established, right? So the jobs are basically well divided. So you get to work on the data science analytics piece. As a data scientist, you probably don't even get a chance to touch the infrastructure because they have an IT department. So it really depends on the companies you're working for. But knowing, so I wouldn't say platform is a must-have, right? If you want to know like what are the must-have skills, and it's definitely Python, SQL, and machine learning if you want to become a data scientist, and visualization, of course. But knowing cloud, knowing big data and containerization is definitely going to make your resume stronger, and you'll have better chance of getting interviews for sure, right? And machine learning, of course. So how much math do we need to know? It depends on the type of jobs you're searching for and how much time you're willing to invest, right? If you have a 2-year plan and you're doing this on a part-time basis, I wouldn't mind spending more time on, the mathematics foundation. It's always important to have. And if you want to become, a very seasoned data scientist, you'll definitely need to be very good at math, linear algebra, calculus, right? But just keep in mind that you're not always going to design novel algorithms or writing new algorithms. Most of the time, even if you understand these math, right, behind the scene, you're still just leveraging the Python packages or deep learning packages to solve a very practical data science problem, right? So knowing the end-to-end workflow and the problem solving skills, right, are all very important. But if we really have to answer this question, then I would say if your goal is to get a job in 6 months to 12 months, you need to know the minimum knowledge, right, of math, but don't spend too much time on math. I'm talking about this from a very practical perspective, because think about how much you need to learn in 12 months, right? Python, SQL, you need to learn big data, a little bit cloud, and you need to spend a few months on machine learning. Right, so definitely, take a math, course, but I wouldn't recommend, for example, reading statistics books, because a lot of those are 700 pages. I'd rather spend more time on, just going through a few projects. Right, you can get a data set from Kaggle, work on practical problems, and then over time, after you worked on a couple of projects, you realize that you actually need to improve your math skills or knowledge in order to understand more advanced algorithms. But at that point, right, you can be more selective. You know exactly what you're looking for, and you can just watch some YouTube videos and take some online courses, but you don't have to go through the entire course, right? So I think get started with problem solving. Even just download a Jupyter notebook from Kaggle and just run through the program and see some early outcome and tangible results. That's going to keep you motivated, because learning programming and math sometimes can be pretty dry and boring, and a lot of people get discouraged because they don't get to see the exciting part, right, which is what you can actually do with machine learning. So yeah, but from a tooling perspective or skills perspective, I think you need to know, right, from a math perspective, you need to at least know a couple of packages. NumPy, right, how to work with vectors and matrices. But most of the time, you're not going to do a lot of NumPy manipulation. It's usually using scikit-learn and pandas, because NumPy is the data structure behind pandas data frames, right? So a lot of times you're basically just working with the pandas operations. SciPy for scientific computing. So these two are definitely the tools or packages you need to know. Data exploration using pandas, matplotlib, Seaborn, Plotly. Some of these are visualization packages in Python, so they can be very useful if you during the data exploration stage, and sometimes you may want to show these kind of visualizations to your team as well to help everyone understand the data distributions, for example. For machine learning and model training, you can work with packages like scikit-learn. When you have imbalanced data set, there are packages that can help you understand that as well, handle that as well. For deep learning, neural networks and Keras, TensorFlow, PyTorch, you name it. There are so many different tools you can work with, but just keep in mind that tools are just tools, right? You're applying these tools in Python programming to solve very practical data challenges. So understanding the workflow is important, because we've seen students knowing how to work with these tools, but sometimes like the sequence, like they apply to a data problem is not the right sequence, right? The workflow is not very very clear. So you should always adopt the best practices, and by reading blog posts, right, reading best practices and white papers, and sometimes can be very helpful. And again, when you learn machine learning, you'll notice that there's so many different things you can learn, and you can get even more specialized in machine learning. You can focus on computer vision, natural language processing. But I would say, if you want to get a regular data scientist job, then just go with, spend more time on NLP compared to computer vision. and just for very practical reasons, because how many how many image processing or computer vision problems telecom, retail, banks are trying to solve, right? A lot of times they're using out of the box solutions, even if they want to build their own computer vision models, and they probably prefer PhDs to work on it. But we are at this learning stage. We're trying to get started, kick off our data science career. Then I would say NLP is probably, or text processing, basic text processing is more important skills to have, because not all businesses deal with images, but definitely all of them will have text data, right? So maybe your company or in supply chain, or in restaurant business, right? Then there's still text that you're dealing with, like the menu data, or you want to scrape what restaurant review and do some text processing. You would like to analyze how people talk about your restaurant and business on Twitter. So a lot of those are unstructured data, and big data is mainly about analyzing unstructured data. So I would definitely recommend focusing more on NLP at the very beginning of your data science journey. And the storytelling side of things, I think it's pretty straightforward. You need to know how to visualize, do visual storytelling, right? This is not just data science. This is data analytics in general. Data analyst, business intelligence specialist, data scientist, all of them need to be a visual storyteller. And the data analyst and business analyst might be focusing more on building dashboards, right, using Power BI and Tableau. But data scientists also need to know how to visualize data, so they understand the distribution of the data, and they can use visualization to identify issues and problems in the data. But they also need to explain the machine learning outcome to the business, right? So visualization will be helpful. Presentation is very important, right? So that's why in our boot camps, students will usually need to do 3 to 4 different presentations, right, throughout the program. The first project student do is usually web scraping, and some people may ask, oh, why does data scientists need to know how to do web scraping? But that's one way for people to improve coding skills. And also collecting your own data is always interesting, because when you show your portfolio to the employer, if you can collect your own data, so that's why, the first project is always very interesting. Everyone has different data set that they, or websites they collect data from. And so that's why when students do the presentation, it's always pretty fun to watch. And from employers' perspective, these are original ideas, because you always need to decide what kind of data you want to collect. And so instead of telling the employer that, oh, I did this, project and the data is from Kaggle, so that means you didn't put into a lot of effort, right, in terms of data collection. But when you look at the real life data science pipelines, data collection is always the first step. So even if you're not collecting your own data from the web, I would still recommend you, load data into databases and write SQL for data preparation, because that's how people do it in real life. You're definitely not going to download your company's database into your laptop and use Python and pandas to do analysis. You're definitely going to use SQL to access the database, because data usually is very big, right? And understanding use cases is very important. You need to know, risk analytics, retail, telecom. WeCloudData has BI courses that cover a lot of use cases. And in our data science programs, we tend to let students work on different types of machine learning problems. And students can always, get, risk data set or telecom related data set for analytics. All right. And just keep in mind that, again, tools are just tools, right? I've worked with a lot of, people who are great at tools, but when you ask them very basic, right, data questions, they just don't have very strong data sense. So I think understanding use cases and also just have a common data sense is very important. So don't just focus on the tools. Always apply that to a real business problem, right? At WeCloudData, we have the real company or project that help you build up real work experience. But if you don't have this kind of opportunities, then at least when you select Kaggle projects or data sets from Kaggle, try to focus on those, Kaggle competition that has some sort of business, context, right? So maybe if you're interested in working for retail, then try to get some interesting data set from retail. For insurance, then you can work on claim prediction and predicting fraud as well, right? So and always try to learn the use cases and incorporate that into your analysis. This is one of the examples, right? So if you would like to learn how to do fraud detection, for example, this can be one reference architecture. It's a much more simplified version of it. But I think ideally when you build portfolio, you know how to collect data yourself, and you know how to ingest it into the data lake. So here, let me do some annotation here. I don't think data scientists will need to, become an expert in data ingestion. That's what usually the data engineers would do, right? So the logo here is a tool called Kafka. That's data ingestion tool, right? So data can come from many different sources. But in our program, data science program, we teach students how to use a similar tool, which is called Kinesis in AWS, to ingest, for example, live Twitter data. Right? And then you need to decide how to store your data in the data lake, whether it's using Hadoop or Amazon S3. So when you show this kind of architect diagram to an employer, you're basically telling them that you actually need to make a lot of small decisions along the way, right? And it's those small decisions that you make that will show the experience you have, right? For example, employers will then ask you, why do you choose Amazon S3, as the backend data store? Have you considered using a database instead of an object store, right? And why do you use Apache Hive for data analysis, right? Or why don't you use Apache Spark directly? And why do you choose Apache Spark ML for machine learning? Have you thought about using PyTorch? So you just need to be prepared, right, to answer this kind of questions. And because you worked on this kind of end-to-end project, so you must need to make this kind of decisions. And you just need to be able to explain why you make some decisions. And it doesn't have to be the perfect answer, right? Because there are many different ways to approach the same problem. You just need to give the reasoning. And then people, because I think companies would like to hire data scientists who can not only do research, but also make the decision, right? You don't want your managers to watch over your shoulder and help you make decision every day and to micromanage, right? So being able to do independent problem solving and propose something is really important skills to have. And when you look at it this way, it's less about Python and SQL or which machine learning algorithm you're going to choose. But it's more about your overall understanding, right, of a data science problem and how to approach it, and how to choose the right tool to solve the right problem, right? And then when we zoom in on the machine learning part, then of course you're always going to make decisions on which type of machine learning algorithms you're going to use to solve a specific problem. So you need to be ready to answer those questions as well. Okay, so I think this kind of portfolio project will definitely impress the employers, but you also don't need to over-engineer it. But just if you don't know how to get started, definitely go talk to a mentor or see if you can meet someone at the meetup or someone who's just approached people online. And a lot of times people are willing to give you suggestions. But just don't when you connect to people, don't just ask for a job referral. You can always show them your GitHub link and ask for suggestions. And I think a lot of people will be curious to at least check out your GitHub repo and see what you've done and give you some suggestions. Now let's talk about the data jobs in Canada. And before we move on, I see some comments. So let me take a look at them and see if we can answer some questions before we move to the next slide. There's a question from Ryan. How much more difficult is this bootcamp compared to other traditional bootcamps? I wouldn't say that our bootcamp is difficult. For example, we actually focus less on deep learning. A lot of bootcamps will try to sell advanced algorithms and deep learning, but we take a very pragmatic approach, right? Most of the people joining bootcamps because they want to get a job in a relatively shorter time period, and they're career switchers and new grads. So your chance of getting a deep learning specialist job is very low, to be honest, if you're considering joining a bootcamp, any kind of bootcamp, because people just don't believe that you'll become a deep learning expert in 3 months. Right. And that's why if companies actually are serious looking for ML engineers and research scientists, education background is very important. Have you done research before? Do you have a PhD and Master of Computer Science, right? That's more important than like the projects you've done in the past, to be honest. But if your goal is to get into the industry to work as a junior intermediate level data scientist, and then focusing on data and building projects is, focusing on building project experience is more important. In that sense, I think all the boot camps are the same. Their goal is to help the student build portfolio and get jobs, right? So WeCloudData tend to focus more on the latter, which is building the project experience, and especially in our full-time boot camp, because the student after 3 months, the traditional boot camps are usually 12 weeks, right? 3 months, you're done. You get some career support, you're on your own. But with WeCloudData, we actually provide another 6 months of support. So the tuition is pretty much the same, but you have 6 more months of support to work on real life projects and build your work experience. And that's going to set you apart from your competitors for sure, because our students are getting a lot of interviews after working on the real projects. There's a question from Mahesh, how deep learning versus machine learning is linked. Is it mandatory to learn deep learning? Good question. So I think nowadays, data scientists will definitely need to know deep learning, right? That's just a trend. In the traditional or the classical machine learning algorithms, a lot of them become very old-fashioned. So people sort of don't use them anymore, right? This field is evolving quickly. And machine learning is part of AI, right? AI is broader, and machine learning is a specific aspect of it, or a big part of AI. But deep learning is another, aspect of it, which is a more advanced version of, because when we say deep learning versus machine learning is machine learning. But people are specifically talking about the deep neural network, right? The neural network algorithm. And when we talk about deep learning, we're talking about deep learning frameworks and architecture, right? And you choose different type of architecture to solve computer vision, natural language processing, problems. So in that regard, I would say classical machine learning algorithms such as decision trees, ensemble models, XGBoost, right, random forest, these are all still very important. I would definitely focus on these classical machine learning algorithms first to make sure that it's all about the job search strategy, and learning is part of this strategy. What do you choose to learn and focus on? I would say because 70% of the jobs out there are operational level data scientist job, and not all data scientists, people who have data scientist title at Facebook actually build machine learning models. So I think you need to focus on your data processing capability, coding skills, and statistics, and also just classical machine learning algorithms. Right? Not like even the AI companies themselves, when they build models, they don't always use deep learning, right? A lot of times XGBoost just works. Could be even better than deep neural networks, right? So just keep that in mind. But it's not mandatory to learn deep learning, but I think sooner or later you will definitely want to learn deep learning as a data scientist. There's a question from Kathy. Are those data science skills that every data science practitioners must master? I think you are probably referring to these skills. I wouldn't say so. Again, if I were to pick, a few ones that I must focus on in order to get a job, then I would focus on Python and Linux. I would say, Python and SQL. Linux will be really nice to have, and GitHub. You don't need to be expert in GitHub, but at least know how to run a few commands, right? GitHub command line to upload your notebooks to the GitHub, and know how to structure, right, your project folder. That's important because as far as I know, not every data science organization actually use GitHub. A lot of them are still doing very old-fashioned way, but version control is something you need to know, right? But if you were to prioritize your time, again, still focus on Python SQL first, right? I would recommend learning one of these cloud platforms, just learning the foundations, the basics, right? And then I would definitely focus on machine learning. And every machine learning project you do, make sure you have a PowerPoint presentation ready, prepared, right? So you're ready to show the employers, and definitely learn some use cases. And then if you have more time, then I would recommend learning, big data, right? And then pick up, some other, tools, but that's already a lot to learn. Um, all right, thanks, Eric. Can you please give me more details on the project you mentioned in risk? So for risk analytics, right, data scientists will, for example, in the banks, you can build, you can build risk models to predict loan default, right? So if you're approving loans or credit card applications, you probably would like to build machine learning models for that, right? The banks can use, FICO scores or scores, credit scores they get from the credit bureaus, but sometimes they would like to, leverage machine learning building house and use the FICO scores, right, as part of the signals, because the banks will collect many other data points, right, and they can use that to make better decision making. So that's one type of applications, right, predicting loans. And in the banks, you have marketing department, so they're always upselling and cross-selling selling products to the customers, right? If you have a debit account, they would like to let's say upsell or cross-sell a credit card to you, some sort of mortgage or loans, car loans, life insurance, right? So there are actually a lot of predictive models happening behind the scene, right? And if you work in, well, again, back to risk, fraud detection models and fraud prevention models. And so there are a lot of models you can build, in the banks. All right, so now let's talk about the job market, right? That's the main topic of tonight. So I would like to mention the job market or the data jobs distribution in Canada. I have some statistics for US as well. I'll start with Canada. So first of all, majority of the data jobs, as you can see here, are in Ontario or in the Greater Toronto area, and followed by Vancouver, Montreal, Ottawa, and Calgary are relatively small provinces in terms of data jobs. But they're booming as well. I have three different job titles here. So data engineers in blue, data analyst in red and purple, and then I have data scientists and ML engineers grouped together in shown in green. And as you can see in Toronto area, there are actually equal amount of data science, data engineering, data analytics jobs. But it varies and depends on when you're going to collect this kind of job market statistics. I actually just did some scraper the other day, and I collected a few hundred jobs in Toronto. So I'll show you some interesting statistics in terms of skill set. This is based on the analysis we did a while ago. I summarized some of these, trends, and I would like to share with everyone, and I will show you the most current version of it in a Jupyter notebook shortly. So if you would like to become a data analyst, right? So these are the top skills you need to have. SQL, Python, Tableau, or Power BI is getting, is definitely catching up. And in a sense, it's sometimes even more popular than, Power BI is more popular than Tableau sometimes. But as you can see, SQL is the most important skills a data analyst need to have, followed by Python, and then you need to be able to do visualization and build dashboard, right? So that's for data analyst. And there's a long tail, right? Some jobs will mention like Spark and Hadoop and Hive. I wouldn't emphasize on that, but that just depends on like the kind of keywords we use for analysis. And for this analysis, because we did analysis on data science, data engineering, ML engineering as well. That's why we have like a common list of keywords we use, and that's why you see Spark and Hadoop, because sometimes it is mentioned in the job posting, but it doesn't mean it's the focus of data analyst. Now I'd like to show you data science. So for data scientist, as you can see, the top 3 skills or 5 skills are Python, R, SQL. Again, you see SQL. SQL is always among the top 3 skills you need to have if you want to work in data, right? And then followed by big data tools, Apache Spark and TensorFlow deep learning, right? So this is the key skills data scientists need to have, but it doesn't have to be TensorFlow. Depending on companies you work for, sometimes PyTorch is more important. And scikit-learn in general is something that every data scientist will need to know. So I'll show you the most current statistics. For data engineers, again, you'll see the pattern here: Python and SQL, right? Top 2 skills for all different data roles. followed by Spark, AWS. So data engineers tend to work with raw data, building data pipelines and doing transformation. So big data skills are very important for data engineers. So you have to know Spark, some Hadoop, and also, Amazon Web Services or Google Cloud. For machine learning engineers, Python, TensorFlow is used for deep learning, right? Apache Spark. Interestingly, Spark is important for ML engineers as well because, when you automate ML pipelines, sometimes, ML engineers are dealing with raw data or big data as well. So you need to know how to use Spark to, pre-process data for machine learning problems. So before I show you the experience requirement, I would like to show you a Jupyter notebook I wrote. We collected 223 data science job postings from Indeed. So it doesn't have LinkedIn data. So basically did some web scraping, collected data, 200 job postings from Indeed. And I did some unigram, which means it's just keyword analysis, right? So the analysis is basically how many job postings, right? Among those 223 job postings, how many times that specific keyword got mentioned, right? That shows you the significance of that keyword. But we can, of course, do more deep dive analysis using, topic modeling and things like that. But as I said, before you jump into machine learning, even simple visualization will tell you a lot about the data you're trying to analyze, right? So let's see. Interestingly, this is slightly different from the slides I showed you because I didn't filter out those business related keywords, right? So the top keyword here is experience. That probably means that a lot of job postings pretty much all job postings will mention you need to have 1 or 2 years of experience, or job postings will ask for experience in machine learning, right? So experience is obviously a frequent keyword, so it's not very meaningful in this case, right? But again, you'll see from hard skill perspective, Python, SQL, you'll see R, and then business models, right? Analytics. I think data analysis and analytics is important for data scientists, right? I think it's a wrong assumption or impression to have, that a data scientist don't need to do, data analytics. It's all about data analytics actually, and machine learning is just part of it, right? And discovering insights from data, right, is important as well. But statistical, I didn't do a lot of data cleaning. This is probably mentioned in machine learning algorithms. So it looks like stats and math, right, is important. At least, people will ask about it in job posting. So that makes sense. But how much math you actually need to apply, I think sometimes it's very specific. If you work as a product data scientist at Facebook, you need to know A/B testing. Then you need to know, multivariate, analysis, and statistical distributions and significance testing and those kind of things, right? That's just the basic statistics. It's actually not that hard to learn and understand. It's not always about machine learning, right? But of course, ML is mentioned. And then you'll see Apache Spark, knowing how to work with stakeholders. So again, I think the business skills are important here too. Then you'll see AWS, scikit-learn or sklearn, PyTorch, right? Pandas. So I think it's these are common tools, right? But interestingly, if you look at, there's some keywords here, 5, 3, 2, these are the years of experience, right? Asked for a data science jobs, and looks like, a lot of data scientist jobs actually require 5+ years of experience. Some of them ask for 3, 2, but the good news is that, there are definitely junior jobs for data scientists, for data science, right? 1 or 2 years. If you're a career switchers or just getting started, then when a job posting asks for 2 years of experience, everyone can apply. Because the companies are not always going to get the best candidate they need. So they usually will interview people who are, who don't have many years of experience as well. However, I would like to plug in our data science course here now. If you get to work on a real company projects, then you'll be competing in this category. You're definitely going to beat people who have less than 2 years of experience. But that's just how resume works. If you have 6 months of experience, you definitely apply for a senior position. And that's why some of our students, after working on the project for 6 to 9 months, because sometimes students will actually choose to stay on a project longer before they start job search. If they can afford the time, then sometimes they get a senior positions right away. Let's take a look at the diagrams. So it will make more sense when you look at the diagrams, right? So the two words, so machine learning, looks like, a lot of those still ask for computer science background, but don't get discouraged if you don't have computer science background, because those are usually nice to have, because we have a lot of students who are not coming from computer science background and can still get data scientist jobs. And we had a panel discussion last night, and we invited two speakers from Twitter and Meta, and they both work as machine learning engineers, and they were sharing their experience, right? They said on their team, not everyone's coming from computer science, even at those tech companies. So I think hopefully this is encouraging news for you if you don't come from CS background. And again, communication skills, problem solving skills, right? So some of these soft skills are very important: decision making, data visualization. So hopefully this gives you some idea, like what some of the key keywords you should be putting in your resume. So when did you show your problem solving skills, right? When did you have to make a decision on a data science project? So if you have the real project experience, that'll be great. But as I said, when you work on an end-to-end portfolio project, you need to do decision making. So it may not be decision making for a real company, for a real employer, but it's decision making for you to to work on this machine learning project. So make sure you include some of these keywords. All right, I won't spend too much time on this. Let's move on with the experience requirement for data science jobs. All right, for data analyst, again, this is data parsed from the Indeed job postings. But I think last time we did this, it was at least 500 job postings. And as you can see, there are more junior jobs for sure in data analytics, because the hard skill requirement is less than the data scientists or ML engineers, right? So 18% of the jobs ask for less than a year, or they didn't mention the years of experience, maybe. And I would say about 21% of the jobs ask for more than 5 years of experience. If you have more than 5 years of data analytics jobs, like experience, you'll still get paid a lot. The compensation can be really good. I've seen business analysts getting paid, very high salary, in the banks, for example. So years of experience is always, positively correlated with your compensation. But the good news is that if you want to work in data analytics, looks like that's like 60% of the jobs require less than 3 years of experience. So you should apply for those jobs. For data scientists, this is probably consistent with what we see here, right? A lot of the jobs ask for 5 years of experience. So 34% of the jobs, when we did the analysis, asked for more than 5 years of experience, but still, around 55, 60% of the time, the jobs require less than 3 years of experience. For data engineers, that's very interesting, right? Companies either ask for 3+ or 5+, and that's why you see the 3 years and 5 years, in total, they're like, 60, 70% of the jobs require more than 3 years of experience. So there's less junior jobs in data engineering. And for machine learning engineering, it's even more, like the demand or the requirement for experience is even higher. So that's why usually people start, with data science and then get into ML engineering, or companies are looking for, software engineers who have done a couple of years of software engineering and then get into ML engineering. Hopefully this is useful. Now let's move on to the salary discussion. So this, it's very hard to collect real salary information, right? So this data is from Glassdoor. So it did some, aggregated the data and did some visualization. But as you can see, for a junior data scientist role in Canada, the average compensation is around 87,000. right? So this is the 80,000 mark. And then the yellow line here is data science. So 87,000, slightly higher than software engineer, which is great. But keep in mind that these are salary information collected from data scientists, but that will include data science managers, senior data scientists, and junior data scientists, right? It depends on who responded to those surveys. So it's definitely not the entry level, but with WeCloudData in Canada, our average graduate salary is around $84,000, which is pretty close to this market average. Considering it's the first data science job, we're actually doing really well. For senior data scientist position, as you can see here, it's around 100,000. That's the average, right? But I've seen senior data scientists getting paid, more than $150,000. It's quite common nowadays. So definitely, that's why probably why a lot of people would like to work in data science. It's well compensated, right? And it's getting close to the senior software engineer salary, which is around 106,000 in Canadian dollar. Now, in terms of the distribution by province, I think I showed you some statistics, but it's not surprising to see Toronto being dominant, right, in the data jobs in Canada, followed by Vancouver and Montreal. Now let's take a look at United States. As you can see on the left-hand side, we collected tens of thousands of jobs here, basically, from Indeed. So this sample size is pretty big. And there are actually more data analytics jobs, right, in general in the United States, followed by data engineering and data science. But this is very much seasonal. So the numbers will fluctuate. Sometimes you'll find more data scientist jobs, ML engineers, because as you can see, most of them require more than 5 years of experience. That's why we'll see less ML engineer jobs. It's more advanced, and a lot of companies are not there yet. They're just building their data science practices. They're not really deploying models in production yet. But I think the demand for ML engineer is going to increase rapidly in the future as well. But you're always going to need more, people working on data analytics and data science than, machine learning engineering, because it's more specialized. In terms of the distribution of jobs by states, United States also sometimes publish, right, labor market statistics. I think they refreshed the data recently. I didn't work with that data, but this is just based on data we collected through Indeed. So should be a pretty good reflection of the reality. But the number is a little bit outdated. I think we did it last year. And as you can see, most of the data, right, come from the Bay Area, probably, California, followed by Virginia, New York, Texas. And at the time we collected the data, interestingly, there are more data scientist jobs from New York. But I'm pretty sure if you do the data scraping, another day, then San Francisco or the Bay Area will have more jobs as well. The salary information, for senior data scientist, the average is 134. This is US dollar. So it's a pretty big gap between the US and Canada, considering the currency, difference. And looks like it's even higher for senior data engineers. Because I think, especially in the Bay Area, the senior data engineers oftentimes work as senior software engineer. As you can see, you can tell software engineers get paid really well in the United States, especially for the big tech companies. But it's not too shabby for a data scientist. It's definitely great compensation, and these are just base salaries. I think if you work for big tech or startups, and there will be other bonuses. So and signing bonuses, and also your total compensation, right, including all the stock and options and stuff, sometimes can be well over $200,000 as a senior data scientist. These are just the comparison, right, of all the keywords we analyzed, and if you looking at this, looking at different roles, and hopefully that gives you a pretty straightforward view of what's important for different roles, right? First of all, Python and SQL is, they're always important, right? SQL less so for machine learning engineers. ML engineers tend to focus more on machine learning and actually writing, Java, C++, or Python code to deploy models. So they're less likely to use SQL. Makes a lot of sense. It looks like this is rank ordered by data engineering, but Tableau really stand out for data analyst, right? R as well, but data scientists even more so for R. And TensorFlow is really important for ML engineers, PyTorch as well, right? All right. Now, we also did some survey a while ago. We collected, data from our meetup attendees. So we asked them questions like, how many data science interviews have you received, this year? I think this is the year of COVID. And 76% of the meetup attendees, I think the sample size is bigger than 100. We collected that statistics from a couple of events. It's not super representative, but the trend is still, I think meaningful. So 76% of the folks who attended our meetup received, right, less than 1 interviews or less than 2, which makes sense because not everyone are job searching yet, right? And 20% of them received 2 to 4 interviews that year, and very few people received more than 5 interviews. When we asked them a follow-up question, what's your biggest challenge in landing a data science job? Lack of skills, lack of real experience, don't have a portfolio, cannot pass interviews. These are some of the prominent answers, right? So 46% of the folks said they don't really have the right skills. So these are probably the beginners, right? People who would like to get into data science. They're at the very beginning of their journey. And then a lot of people, like 73%, of the people said they don't have the real experience. That's probably because many of the attendees are career switchers, right? And 40% of them don't have a portfolio, which is good. It looks like a lot of people know that building portfolio is important, right? So only 40% of them don't have a portfolio, and some of them cannot pass interviews. You see the number 15 here because 76% of them actually don't even receive interviews, or maybe they're not job searching. So that 15% is the 15% out of, I guess, the 25%. So it's quite significant, right? So interview skill is also very important. So having mentors around to support you during your job interview is very very helpful. And you don't get to learn these from university programs because they tend to focus on the theory and also skills, but they don't really teach you how to build portfolio. This is where boot camps are usually very useful if you want to get a job sooner, right? Because they tend to focus on the thing that matters the most for job search. But typical boot camps tend to emphasize less on the theory side of things. But for a very machine learning focused job, maybe the skills you learn from the bootcamp will not be enough. Like you definitely need to keep learning, right? So once you start learning data science, you should not stop. You should always keep learning new skills. I won't dive into details. I would like to leave some time for questions as well. So I'm going to pause here. Maybe for the lack of experience, right? My recommendation would be just working on portfolio project, right? And if you join WeCloudData's bootcamp, you get to work on the real client project. But just in general, when you work on a portfolio project, my recommendation would be at the very beginning, I mentioned that you need to build something end-to-end, right? Ideally, you collect your own data and then you do data cleaning, right? Apply SQL and databases as well, before you do machine learning. Don't just download a data set from Kaggle and train a bunch of models. That's not very effective, right? And also, if you have worked on something that's, that has bigger scope, try to, create some sort of architecture diagram, right? Your data science architecture. That's kind of tools you use, cloud, and write a documentation or just create a project summary. We used to ask students to bring their, print out their portfolio project and put that in a binder and take it to in-person interviews. But due to the COVID, we don't do that anymore. But there are better ways to do that now, right? You can publish on, as a blog post. You can even just upload that to Google Drive and share the link with hiring managers, and hopefully they can open, your portfolio project and take a look at it. This is similar to GitHub, but GitHub is more like, focusing on the code and a project structure. You do want the hiring managers to see the presentation deck. You want them to see any kind of dashboard you've built, and also a project summary. I don't think they'll have a lot of time to go through it, but the job is for someone who's well prepared. So just always putting extra effort so you're well prepared for the job and opportunity, right? If you don't have a portfolio, then WeCloudData can definitely help. We collaborate with many different companies and put the students on real projects. And you're not alone on those projects, right? Typically, there will be 2 to 3 students working on a real project, but we also have project managers. And for some of the bigger projects, we will have 2 to 3 full-time staff consultants working on a project as well. So you're going to get a lot of support as well. So I think this will set you apart, because no more Kaggle. Kaggle is becoming less effective unless you can do very well in the competition. Your ranking is good. Otherwise, most people treat Kaggle just as exercises, unless you can create a really nice story, right, out of the Kaggle project you did. So storytelling is not just for, right, the working environment, and like you need to do storytelling for yourself, like, because in an interview, you're selling yourself, selling your skills. So you need to do storytelling as well, right? In terms of interviews, WeCloudData graduates will get a lot more interviews. 40% of the students, when we did the survey, they had more than five interviews, which is pretty good. Some students, they will have less than 5 interviews. That's because, sometimes they got referred to different companies, so they actually didn't do a lot of interviews. But sometimes when we did the survey, the student actually haven't got enough interviews. That's always the case. There are always students who couldn't get enough interviews, but when you struggle, when you need help, at least the mentors will be around to support you. So we always encourage our students to ask for help, right? Because as I said at the beginning, even though most of the time when we do marketing, we'll say you have 6 months of career support, but we have never stopped supporting the student, beyond 6 months. So that's why we get really good results. Okay, last couple of slides. I would like to give some suggestions in general. I think career switch to data science is not easy. It requires dedication. If you're just about to get started, just set the right expectation with yourself. Talk to bootcamp graduates. Ask about how much effort they put into learning. I think a lot of our bootcamp students will tell you that it's actually not easy. Some students not coming from a coding background will actually struggle quite a bit at the beginning. Some students are a little bit slower to adopt, right, all of these new technologies. But I think eventually, at the end of the bootcamp, a lot of students will be pretty comfortable with applying these tools. But knowing how to work with tools and being ready for a job is still different. So working on projects will definitely help the students, whether it's real project or portfolio projects. Definitely do your research. I think attending this kind of meetup will give you some good information, but you should always do your own research, right? So the job market better, and don't just research on LinkedIn or Indeed. Go talk to people, reach out to people on LinkedIn, and even though a lot of times people don't respond, but there are strategies and tactics you can apply to get higher response rate. But always offer people something, right? You can at least when you ask them for suggestions, make sure you have your portfolio ready, and then share your portfolio with them, and they're more likely to respond, right? If you're at the beginning of your journey, definitely follow a very structured curriculum, so you can focus on learning the right thing, because the things you can learn is endless. There's so many you can learn, so much you can learn. But again, time and prioritization is important, right? We're always working under different kind of constraints, and time is a big constraint we have. So if you would like to get a job relatively sooner, following a structured curriculum is important because you don't have to get distracted by many different things, right? Because when you talk to 10 different data scientists, they'll actually tell you to learn many different things, right? But I think you need to focus on learning the absolutely important things to make sure you cover the ground, and then you can. It's just like building a a building, right? Building a house, and you need to have this strong foundation. And if you're ever considering a bootcamp, you can always have a free trial and watch some of the the recordings. You can always ask for it. I think most of the bootcamps will allow you to do a free trial, or just ask for past course recording and see if that's the right fit for you. Bootcamps are not for everyone. We have 10% of the students will join the bootcamp, and the first week they'll probably drop out because they got overwhelmed by the program. Maybe it's much more intensive than they have thought. I was talking about the full-time bootcamp. Part-time programs are usually better. Find a mentor who can give you guidance. Right? So having someone to give you suggestion and feedback along the way is very important, because a lot of times when you work on something, you just don't know if it's the right approach or if it's the best approach. So talk to someone who's more experienced, and mentors offer tremendous amount of value in this case. So WeCloudData Bootcamp also has a mentorship service. So we have a separate mentorship entity, which is called wecareer.ai. You can go to wecareer.ai and request, a meeting with, our, career advisors. But in our bootcamp, we always have career mentors included in the package. So students are always going to get 6 months of career support after graduation. And work on hands-on projects, right? Building portfolio. That's the only way you can prove to the employers that you can get the work done. Because without seeing this kind of proof, it will be very hard for you to get an interview. So make sure you work on not just 1 or 2. I think you should at least have 3 to 4 portfolio projects that you can put on the resume, and then that will catch people's attention. Okay. Again, building a portfolio, and then also keep applying for jobs. We've worked with a lot of students who are very picky. They're either picky with what jobs they apply for, or they just don't work hard enough. So sometimes the students will come to us and complain and say, well, that was before COVID. We get to meet student every day in the classroom. Right? Sometimes, during a break time, the students will complain and say, "Oh, I'm still not getting any interviews," and the students are starting to panic right after graduation. When we ask them, "How many jobs have you applied for?" the students said, "I applied for 20 jobs." So obviously, you need to apply for more jobs, because I think in the past, if you have the right experience, you apply for 20, 30 jobs, you should get a few interviews. But today's job market is very different, because there's so many boot camps, right? So many career switchers, so many university programs, and a lot of great content online on MOOCs. So there are a ton of people in the job market who want to get into data science, want to get into data industry. They have portfolio projects, they have the skills, they have the right keywords, right? So your chance of getting interviews will just become lower because of the competition. So you definitely will need to apply for more jobs, and also tailor your strategy as you move along, because every time you apply for 50 jobs, and based on the feedback, right, and based on the response, and sometimes no response is the response. When you apply for 50 jobs, you don't get any interview, that means, well, update your resume. Something's wrong with the resume, not your skills. Fix the resume, and then once you start to have interviews, then you will need to start getting feedback on your interview skills. When you get rejected, that is some sort of feedback, but you should proactively ask for feedback, right? Or even better, always give the feedback, or how the interview goes, and give that feedback back to your mentor, and the mentor will be able to help you, make improvements and help you with mock interviews. Tailor your resume. I think everyone knows that, and be extremely patient. And it's just like growing your YouTube channel. Sometimes, if you know what I'm talking about, like, if you want to become a YouTuber, the beginning is always tough. Like you uploaded 10 videos, you're hoping to get thousands of views, but unfortunately, maybe only 1 or 5 or 10 views. But at a certain point, if you keep doing this, right, eventually it's going to explode, assuming that your content is good. But job search is the same. Sometimes our students will go through the emotional roller coaster. Like they apply for 100 jobs, they don't hear back. But all of a sudden, they start to have like 3 interviews in a week. So you just need to be prepared, right? When that happens, you want to make sure that you can, get hold of those opportunities. You don't want to screw up with the interviews. So one of my suggestions for data science people who want to get into data science is that you should apply for data analytics jobs as well and go to those interviews, right? And then you need interview opportunities to be able to express yourself and practice and work on your pitch until you make it perfect. And when finally the data science or machine learning engineering interview opportunity come, you don't want to screw it up. You want to just seize it right away, right? So yeah, so that's my my suggestions for the career switchers. All right, just a couple of more slides to summarize what we discussed, and I would like to maybe explain the data science program a little bit more. So it's right now available on the West Coast. So it'll be the Western time zone, and ask about discount if you're interested. So we have the full-time, project only, and also part-time opportunities options. And just to show you a little bit more of what you will learn. The full-time bootcamp is 3 months. It's actually 14 weeks, right? So you finish the 14-week bootcamp and then you start the real project and career mentorship. And in the bootcamp, we cover SQL. The first 1.5 week, we cover SQL databases, and we'll move on to Python programming. And then we start data science with Python and machine learning. We spend quite a bit of time on machine learning before we move on to big data, right? So we cover Amazon Web Services and Apache Spark. And students also need to complete an end-to-end big data project. So they will be collecting real-time Twitter feeds, ingest the data into S3, and then analyze the data themselves. And of course, we help students build portfolio projects. So this is the typical bootcamp package, but as I said, WeCloudData has a lot more to offer. So I think we are the only bootcamp that can offer you a real client project, right? So it's not, some bootcamps will offer real project, but they get a data set from the client or whatever partners. The partners doesn't really care what you do with the data. In our case, it's all real projects. You join a project team, you need to deliver. Some of those are internal projects, right? A lot of those are external projects, depending on when you join the boot camps. Sometimes there will be more external projects, but internal projects are also very, very interesting. So students will work on real project for 6 months, and we also provide career mentoring at the same time. So student will be paired with a career mentor when they are ready. So it doesn't have to start right after bootcamp. The students we have the flexibility for the students to tell us when they're ready, and then the 6 months career support will kick off. But most of the students will start the real client project right away. So that's the full-time program. And as I said, if you already graduated from a bootcamp or you have a master's degree in computer science and you're just lacking a little bit, work experience, because you cannot get enough, a lot of interview, then just join the real client project, program that includes the career mentorship as well. So you don't have to join any kind of bootcamp program like training. Just start the real client project right away and get mentored along the way and get career support. But you do need to pass our skills test, right? So you need to know Python in machine learning already. So if you don't have the skills, no one's there to train you. So you will not be able to complete the project. So you definitely need to have some experience before you get admitted into the program. In the part-time program, the only difference here is that part-time program doesn't have a real project attached to it, right? But it can be purchased as a separate package. So if you want to work on real project while enjoying the flexibility of learning, and you're not in a big rush, then if you include the real project, then the price will be exactly the same as a full-time program, but you do have the option, the flexibility, right? So now it's a 6 months of learning. exactly the same content, but instead of like 5 days a week, you'll be learning 2 days a week, Wednesday evening or Thursday evening for 3 hours, and then Saturday or Sunday for about 7 to 8 hours. So it's about 10 to 12 hours of lecture and lab time. And Monday to Friday evening, we have office hours. So TAs are always going to be available on Zoom. So you can ask live questions, and you can, of course, ask questions on Slack as well. And then we have the real client project option, and career mentoring is always included. So that's the end of my presentation. So hope this presentation is useful and help you understand the job market better. And now I can answer more questions. Where do we begin? Thanks, Eric, for answering questions along the way. There's a question from Brian. Is lead code very important? Yeah, I think they're important. And it depends on the employers, right? So if you would like to work in big tech companies and some startups, lead code is more important, relatively more important. So like, studying, data structures and algorithms, these are computer science problems, right? So usually boot camps don't teach you data structure and algorithms. You have to basically learn that on your own. But there are a lot of great resources online already. And at WeCloudData, we actually do have some TA office hours that we cover lead code. We did that in the past, but we don't do that for every cohort. Sometimes it depends on demand. But I would say if you want to work for the big tech company, you definitely need to work on lead code. But if you are applying for jobs, in general, in let's say in financial services industry, in telecom, retail, e-commerce, it's not a must-have. But coding test is a must-have. Like most of the companies will give you some sort of coding challenge, right? At least make sure that you know Python, SQL before you get to talk to the hiring manager, because they just want to save time. They don't want the hiring manager to talk to someone and then realize that they can't code. So yeah, you definitely need to pass the coding round, but not necessarily lead code kind of coding, right? Depending on the companies you're applying for. There was a question from Kathy: in a Canadian workplace, do these 2 years of work experience really only take 2 years, or do you have more experience when actually hiring, the better? Yeah, so this is, the years of experience is what they desire, right? They want someone who has, let's say 2 years of experience and 5 years of experience. I can give you an example. We were referring a student to TELUS, right? So we worked with their HR team and they said, I need someone who has at least 5 years of experience, right? And then we referred a student to TELUS, and that student actually did, I'll show you what, this portfolio is what that student was from that student, right? And he built some end-to-end data science project, but a lot of data engineering as well. So that was an interview, that was a data engineering hiring opportunity. The student had 2 years of mechanical engineering work experience, right? A master's degree in mechanical engineering, no experience whatsoever in data science and data engineering. And he has really good portfolio, right? And we still, referred students to them, and they explicitly told me that they need someone who has at least 5 years of experience. But the student still got the interview, and the student passed, made it all the way to the last round. And then the HR was telling me, giving me feedback. He said the student was so good, and, he got 10 out of 10 on technical. And unfortunately, the student didn't get the offer because, in the last round, he was interviewed by 2 directors on the business side. So the student didn't have a lot of business experience, so he didn't do very well. But still, it's very encouraging. I'm just trying to say that when companies ask for 3 years of experience, if you have 0 years, zero experience, you should apply, because this is a filtering problem, right? When the companies want to hire someone who has 3+ years of experience, they post the jobs, right? Um, a lot of people meet this 3+ year experience, meet the requirement, but majority of them are not actively looking for jobs. So they're not applying for this position. For those people who do, right, and some of them get filtered out because of the skill sets or didn't hit some keywords, right? And then finally, when the companies find, let's say, two really strong candidates, and then they went through a lot of rounds of interview, and then they didn't take the offer because they got a better offer from some other companies. Because if they're strong, then they can easily get interviews, they can get multiple offers. And then the company oftentimes realize that, well, they just can't get people they want, right? So even with WeCloudData, when we hire people, right, in the operation team, on the faculty team, sometimes people get multiple offers, they don't necessarily always come to us, right? And then the companies will start to realize that hiring cost is really high, right? And that's why sometimes they rely on the, external recruiters to help them find the best candidate. They're outsourcing it to save cost, the time cost. Why is it that data engineers have higher salary than the data scientists? Some data scientists have higher salary than data engineers. It really depends. There are seasoned data engineers who get paid really well. And I think that the chart I showed you was the numbers from the US. My assumption here is that in the Bay Area, a lot of data engineers, all right, if you want to become a senior data engineer in those big tech companies, you're pretty much a software engineer first. Otherwise, it will be very hard for someone to become a data engineer. But that's not the case with non-tech companies. Yeah, so we have a data engineering program as well. We have a lot of students who's not coming from computer science background. They still get data engineer jobs. But why it's higher, I guess, it's probably because a lot of them are software engineers. And right now, data engineering is very hot as well because it's relatively new compared to data science. Because a lot of companies, they're chasing the data science trend, moving to the cloud, starting to do machine learning. And then later on, they will realize the importance of data engineering because not all data scientists can write, good quality code. And data pipelines is not that straightforward, actually. So it requires a different set of skills. And a lot of companies start to realize the importance of data engineering. And there are not a lot of data engineering training programs out there. That means there are less data engineers candidates out there. And that's probably why the demand and supply, is not balanced. And so that's why the salary is relatively higher. If companies cannot find good quality data engineers, they have to raise the price, right? Is there certification after completion of the program, and how's the development process from other alumni? Yeah, so there, if you live in Canada, you will get a diploma. So this is an I should say it's a program that's approved by the Education Ministry. So you'll get a diploma. And for students from the United States, you get a certification. You get a certificate. Yeah. There's another question. Where did the student get the data? Did he or she web scrape? Yeah, we recommend the students to do web scraping. So the students will be scraping data. That's the first project they do. They don't necessarily use the data they scrape to do their machine learning project, though. Sometimes we share the data with students, but a lot of times we encourage the students to still find interesting data set, and you can use Kaggle as the data source. But it's all about how you frame it, right? So if it's a Kaggle data set, try to find a more complicated data set. I'm definitely against finding a Kaggle, data set that only has one CSV file, because that means you just do pd.read CSV, like you just need to read the CSV file and then start doing data preparation. Ideally, it's a Kaggle data set, a project that has 3 to 4 different CSV inputs, and you can load the data into a database and write SQL queries to prepare the data. That's how people do it in real life. You can write SQL, to prepare the data, and then load the data into Python and start doing data preparation for machine learning. So that sort of will, enrich, right, your project and make it look more real, because that's how real life data science work. Yeah. Right now, the full-time program is only available on the Eastern time zone. On the West Coast, we have part-time programs, and the full-time program will be available sometime next summer. So yeah, stay tuned. Is there a higher success rate between full-time and part-time? Well, that's such a great question. To be honest, it's definitely much higher on the on the full-time side. That's because for the full-time students, if they join bootcamp full-time, they're dedicated to career switch, because a small percentage of the student actually quit their job, right, to join the bootcamp. They're very motivated. And a lot of students are just in the job market. They're new grads, for example, and some of them are, sometimes they got laid off, for example, during the COVID or whatever. So they have the time, and what they're going to do is just like after graduation, work on real project, and then job search, right? So then of course the job success rate is going to be higher. We actually only finished the second cohort of the bootcamp, so we still haven't collected the job success rate number from the part-time program from the first cohort yet. But as far as I can tell, some students get jobs, but a lot of students that we talk to, they have not even started job search yet, because we the one thing we can monitor is how many students have been in touch with the mentor, and unfortunately not a lot of them have been in touch with the mentor. So we can't really push the students in a part-time program to look for jobs, because they have full-time job, right? But they have a plan. Some of them is 2 years. So it depends. But what we can promise is that when the student need help, we're going to provide mentorship, and then we can keep letting the student work on the project until they find a job. Yeah. Any other questions? No problem, Ryan. Okay, if there's no further question, I'd like to thank you for joining this session and staying till the end. Thanks for your patience, and I hope this session is useful. We have some other events scheduled in the next couple of weeks. Oh, and there's one good news I would like to share with everyone. So Eric and I, and also our data engineering team, faculty team, we're planning to do a free course. So there will be a 3-night free BI course, a 3-night free data science course, and also 3-night live free data engineering course. So it's going to span over 2 weeks. So it's not the same as this kind of information session. It's actual live courses, and it's free. So if you want to learn more about data science, especially when you just are getting started, I think the free courses will be very helpful for you. And come and talk to us, talk to the instructors, and we'll help you get started. So that information will be posted on our meetup. So you'll definitely be in the loop. So yeah, thanks everyone. I'll see you guys next time.